Okay, this is the second half of section 6.6. How do you solve radical equations with extraneous solutions? Okay, so what is an extraneous solution? An extraneous solution is an apparent solution that does not work. Okay, so you solve it, you get a solution, you plug it back in, it doesn't work. Okay, so let's try a couple of these. So this one here, we need to raise both sides. The square root is isolated. Remember, that was our first step. So when I square both sides, something happens though. When I square both sides, the square root goes away here, and I get 7x plus 15 on the right side. But how do I square x plus 1? What I have to do is I have to multiply x plus 1 times x plus 1. Okay, so it's not x squared plus 1. Don't just square these, you have to FOIL, multiply it out. So you're actually going to get x squared plus x is plus 2x plus 1 equals 7x plus 15. Okay, so now how do I solve these equations? This goes back to chapter 4, solving quadratics. I got to get everything to one side, so I have to subtract 7x on each side and subtract 15. So I get x squared minus 5x minus 14 equals 0. Then how do I solve that? Could use quadratic formula, or I could try to factor, which is the easier way. Remember, that's a diamond problem now. Two numbers that multiply to get negative 14 that add up to 5. Negative 7 and 2. So we get x minus 7, x plus 2. So I get x equals 7, x equals negative 2 as my two solutions. Okay, so now when I do this, I have to substitute these back in, check to make sure they work. Okay, so first let's try negative 7. I wish I would have left myself some more room. On the left side, when I try to do this, if I plug 7 in on the left side, 7 plus 1 is 8. If I plug in 7 on the right side, 7 times 7 is 49. 49 plus 15 is 64. I get the square root of 64. So I get 8 equals 8, and that works. Those are equal. So that one's okay. So this 7 is a solution. When I plug negative 2 in here, negative 2 plus 1 is negative 1 on the left side. When I plug negative 2 here, I get 7 times negative 2 is negative 14, plus 15 is 1, so I get the square root of 1. So I get negative 1 equals 1. Those are not equal. Okay, so negative 2 is an extraneous solution. Okay, let's try this one. So when I square both sides here, square the left side, I get 10x plus 9. Square the right side, I'm going to get x plus 3 times x plus 3, which is going to give me x squared plus 3x, and 3x is 6x plus 9. So let's get everything over to this side. I'm going to get x squared, subtract 10x is going to be minus 4x, subtract 9, and that's going to be 0. So this is what I would get there. Now how do I solve that? Well, I solve that by factoring out an x, like so, and then setting each equal to 0. So x equals 0 and x equals 4 are my two solutions. Okay, so let's try each of those. Plug in 0 here. I'm going to get 0 plus 9 is 9. So the square root of 9 would equal 0 plus 3 is 3. So 3 equals 3, so that one's okay. Let's try 4. 10 times 4 is 40, plus 9 is 49. So I get the square root of 49 on that side. 4 plus 3 is 7. Square root of 49 is 7, so 7 equals 7. That one works too. So in this case, they both work. So you're going to either get them both to work, or you may get only one of them to work. And you extraneous solution. Okay, so that's how we do those. 3 and 4 are pretty straightforward. The nice thing about number 3 is what happens when I square both sides. The square roots both disappear. So I end up with 2x plus 5 equals x plus 7. I solve that like I do any simple linear equation. Subtract x from both sides. So I get x plus 5 equals 7. Subtract 5, so I get x equals 2. So that's what I'm going to get on that one. Similar here, looks different, but when I bring this term and bring it over to the other side, it becomes positive. So I get cube root of x equals cube root of 2x plus 3. So when I cube both sides, I get x equals 2x plus 3. And now I can solve that. So if I subtract 2x from both sides, I get negative 1x equals 3. Divide by negative 1, I get x equals negative 3. Okay, so those are pretty straightforward. Now we're getting to the more difficult ones here. Notice the difference between 5 and 6 and 1 and 2. On 1 and 2, I just had a 1 square root, and I could isolate it on one side and then square both sides, and the square root would go away. Problem with this one is I have a square root on both sides along with something else. Okay, so when I square both sides, it's not just going to get rid of the square root. I end up having to square both sides twice. So these are kind of long problems. So what I'm going to do here is I'm going to square both sides of the equation. So the right side's easy. I square that, the square root goes away, I get x minus 2. But how do I square that? Well, I'm going to basically multiply, I'm going to FOIL. I'm going to multiply it by itself. Okay, but you got to be careful when you FOIL this. When I multiply the first terms, this times this, square root of x plus 6 times the square root of x plus 6, the square roots cancel out and I just get x plus 6. Okay. When I multiply this first term times the negative 2, I'm going to get negative 2 times the square root of x plus 6. Same thing when I multiply the inside terms, I get negative 2 square root of x plus 6. And then when I multiply the last term, negative 2 times negative 2 is 4. So that's what I'm going to get. Now I can combine these middle terms. So I'm going to get x plus 6 minus 4 square root of x plus 6 plus 4 equals x minus 2. Okay, so now I still have this square root here. So now I'm going to isolate this square root on one side and get everything else to the other side. Okay, so let's see. We've got, actually when I subtract x from this side, the x's are going to cancel. So I'm going to get a 6 plus 4 is 10. So I get negative 4 square root of x plus 6 plus 10 equals negative 2. So subtract 10. So that gives me negative 12. Divide by negative 4. I get the square root of x plus 6 equals 3. So now that I've isolated that on one side, I can square both sides. 3 squared is 9. Subtract 6, and I get x equals 3 on that one. Now, these ones we should check again for extraneous solutions. I only got one solution, so I'm going to assume it's correct, but let's substitute it in here. If I substitute it on the right side, 3 minus 2 is 1, so the square root of 1 is 1. So on the right side I get 1. On the left side I get 3 plus 6 is 9. The square root of 9 is 3. 3 minus 2 is 1. So it works. So that's how I'm going to have to do these ones when I have square roots on both sides along with something else. Same thing on number 6. I've got the same situation. What I'd like you to do is try this problem, work through it, see what kind of answers you get, bring it to class tomorrow, and I want to see how many of you can get the correct answer. Make sure you check for extraneous solutions. So that's it for section 6.